My name is Lyndsey Padget, and I am a Git enthusiast. I'm going to be hosting a pre-conference workshop called Master Git in a Day at PAS Summit 2018. It's going to be on November 6th, so you're not going to want to miss it. Today, we're going to be talking about the difference between merging versus rebasing. So let's look at conceptually what a merge is. You've got the master branch here, and maybe you work off of develop, it doesn't really matter. From there, you've diverged and created your own branch called feature 123 or whatever. At some point, you want to get that feature back into master or whatever branch it came from. This is typically done via pull request or something like that. Before you do that, though, you're actually going to want to take the code from the source branch and get it into your feature branch. That way you can resolve conflicts and ensure that everything works before actually doing that final merge. You want to get master's code into the feature 123 branch, and you do that with a merge. Then at some point you're going to take feature 123, merge it back into master. And again, this is typically done via pull request, but at that point you know that all conflicts have been resolved. So let's take a look at a repository that I've set up just for this purpose. I have a repository here called repo merge. And as you can imagine, I'm going to have another one called repo rebase so we can compare and contrast the difference. So in the master branch, I've developed a very simple site, index.html. If you click this button, some random numbers happen. And that commit that I'm showing you there is actually 176D72B, et cetera, and locally, that's what I have checked out here. So that's what the site looks like at this point. You can see here that I've got both repositories. The repo merge is the one we're in now. So even though we've checked out this particular commit, this is the development that has happened in the meantime. So let's move to the latest on the master branch. And we're going to do get log to ensure that our local history matches up with the history of the repo in the cloud. Of course, in this case, I'm using GitHub, but you could be using any Git service provider. So yep, that looks good. We're going to get out of get log. And at this point, we're going to move over to our feature branch, feature 123, okay? We're going to do a get log again. We're just making sure at this point that the history that we have locally matches up with the history of this branch in the cloud, and it does. But the problem is that development has happened on the master branch, and we aren't able to see that reflected here in this branch. So what we're going to do is say git merge master. Okay, and it looks like we have a conflict. So S is my alias for git status. I type that many, many times in a day. It's index.html. So we're going to take a look there. And you can see that in the master branch, a footer has been added, right? So we're actually just going to take this footer and add it here. Yep, that looks good. We've resolved that conflict, and the command line is telling us exactly what to do. We're going to say add. Dot means all of the files. In this case, there's only one, so we're adding it to mark it as a resolution. Again, get status tells me where I am. That's S for status. And it looks like we're ready to conclude the merge. Git commit. And I'm going to say merge in develop, because that's what this commit represents. Okay. Now, if I do git log, I can see that merge and develop has happened here. This is going to represent all of the changes that have happened in the meantime on the master branch. So if we go back to our diagram here, it's this work, right? It's these two commits that have happened, and we're merging it into the feature 123 branch. So let's take a look at it locally and just make sure that everything looks good. Great, so now we have a header and a footer The footer has happened in the master branch, and the header has happened in our feature branch. We need to get feature 123 local history onto the cloud repository. We need to push that up to the origin so we can see it reflected there. Git push ought to do it if we have an upstream branch associated to feature 123, which in this case I do. And over here I can refresh feature 123, and I can see that merge and develop commit hash represented here. So now we're ready to create a pull request. I'm going to go to just the main code tab here, and I like this feature of GitHub. It shows you the last branch that has been touched. Yes, that's the one that I want to create a pull request for. And nicely, we see that all of the conflicts have been resolved. I did that in my local repository on my branch where it was safe to do that, and if I screwed it up, no one would know. So everything's resolved. We're ready to create this pull request. I can skim down here and see, give it kind of a final pass, and yep, go ahead and make the pull request. Okay, and so let's pretend that I've gotten my approval and we're ready to merge. There are a couple of different options here, and I'm not going to talk about them in too much detail. I'm just going to leave this as the default. Create a merge commit. And I say, yep, go ahead and merge that. You could delete the branch or not. It's up to you, and a lot of teams have preferences about how they do that. So if we go back to code, we can see that this was the merge commit that came from master into my feature branch, and this is the merge commit of my feature branch going back into master. So you can see that we have those two commits. They look much like pictured here. So let's look at rebasing so we can compare and contrast the differences. We would have created a merge commit before. Now we're actually going to replay the feature branch commits on top of master or whatever branch it came from. So it's going to end up looking like this. One of the advantages is that you don't have a merge commit, which represents when that code came in. On the flip side, you don't have a representation of when that code came in. Some teams want this and some do not. Ultimately, you want to take this code in the feature branch and get it back into master. When you do that, if you don't use a traditional merge strategy, which would create a merge commit, you can have a very linear history that looks like this. So let's take a look at the repository that I've set up for this purpose. This should look pretty familiar to you. It's the exact same structure as the repo merge. This one's called repo rebase. Everything's the same. Over here, you can see that when I refresh, I've got the same kind of site. I'm at this particular commit again, and if I wanted to show what's happened in the meantime, I can say git checkout master. That moves me to master branch, and you can see that I've added that footer. So now I'm going to move back to my feature branch. Git checkout feature 123. Git rebase master. Okay. You can see that we're in rebase mode because it's got this R here. And if I type status or my alias, which is S, it's going to show which file or files are in conflict. So again, we've got that pesky index HTML. Okay, so we're just going to resolve this conflict. We want to keep this in the header and keep the footer here. Great, save that. Go back to the command line and say git add. And just like before, git rebase continue. Great, now let's take a look. Excellent. Now, just like before, we need to ensure that the local history is represented up in the cloud repository, the origin in this case. So let's look at the history locally, and we'll pull up the history here. And we should be able to see that we have some changes such as footer related things, right? Add a footer, style the footer. Those are the commits that have happened in master and are not reflected here. So we're going to get out of that And we need to push. Now this is going to be rejected, and the reason is that we have actually taken those previous commits and we have replayed them onto master, which creates new commits. Git sees this as a potentially destructive change. This brings me to the golden rule of rebasing, which is to only ever rebase on a not public branch. If you are working with other developers on this feature branch, rebasing is not okay. Because we're rewriting history, we are going to use a force push. Okay, forced update has occurred. We can refresh here, and we can see that some of these things change down below. Now, you can already see the difference between merging and rebasing. Instead of all of the changes from master coming in as a single commit at the head of this branch, they've been infused. So now we're ready to create our pull request. Once again, I can say feature 123 going into master. I can look everything over quickly and see that it looks good. No conflicts, which is what we were looking for. Create a pull request. Now from here, I can scroll down and we can merge the pull request, which would create a merge commit, or we can say rebase and merge. A rebase and merge is going to be more like what we want to create the linear history. So let's go ahead and choose that. And we say confirm rebase. And we can delete the branch or not. We can go over here to code and look at the history of the master branch. Refresh that and see that everything looks very similar to how it looked in our feature branch. So we've accomplished the same goal, but we don't have any merge commits in the history. So that concludes merge versus rebase, and that is one of the many, many things that we're going to cover in depth at Master Git in a day. You're going to learn so much, your head's going to explode, and it's going to be a lot of fun, so I hope to see you there.